And let's close that one. That's not the one I want. That's the one. That's the one I want. I'll go to my whiteboard, share the screen so this will come up on the recording. Okay, Jinglin's arrived. Okay, here's your whiteboard, Jinglin. All right. So how's everyone? All right? Yeah? All good? Okay, we're going to look at some transformations, and we're going to mix that with matrices, and we're going to be leading towards looking at 3i eventually. However, here's the first question. Actually, I'll ask a few questions. Let's reflect. In the y-axis, and we've got an equation which is +1. I want to dilate scale factor of 3 in the y-axis, the same equation, and translate the units left, 1 unit up for that equation. Okay, these are individual transformations. Don't do 1, then 2, then 3. Just 3 individual transformations on the one function. So don't worry about first, second, and third. Just do one transformation each time on that function, and I'm curious to see what you do with that. Going to give 1.5 minutes per question. So 3 more minutes. 2 more minutes. One more minute. Okay, Shin, you're finished. All right. Okay, so let's go through these. Question 1, reflect in the y-axis. Example. In problem solving, choosing any particular point might help. Where will 2, 3 become for question 1? Question 2, where will 2, 3 move to for question 2? And for question 3, where would 2, 3 move to if you had a position? We're just going to do it to any point. We're just going to do any point. Not the equation, just a point. It's just going to be a position. That position will move to another position. Where would the point 2, 3 move to under the transformation in question 1? And where would the point move to if it was transformed as per question 2? And finally, where would that point move to if it was transformed as per question 3? Are you finished, Brendan? Are you finished, Lynn? Jen, are you stopped? Okay. All right. Okay, Shin, that was worth waiting for. Good. All right. Let's go through these answers. All right, I'm going to put a whiteboard background and just put a bit of a scale. So if you had to do this, you could scribble this out on your book. And you see, I can't really teach the lesson until these concepts are understood. So today's lesson, if you can't do these skills, then you won't be able to survive the next level. 2, 3, if this was, that was 2, 3, I'm talking about that position there. Where would that be if it was reflected in the y-axis? Well, there's the y-axis. So the reflection in the y-axis, you've got to be able to see that the reflection, that's like the mirror, the y-axis, it would reflect across to this position, and that's the position -2, 3. So -2, 3. Scale factor of 3 from the y-axis. Well, there's the y-axis. We're going to move that across 3 away, multiplied by 3 from the y-axis. So this is a unit of 2, and this measurement will be 6 units. So this is 6, 3. So that would go across to 6, 3. Okay, 2 units left. Jump, jump, 1 unit up, jump, and it would go to the point 0, 4. So that would go to 0, 4. What we did the other day was that the x, a reflection in the y-axis, what would happen to the x and what would happen to the y? All right, so you've got an xy and you've got the x image and the y image. What happens to the x value when you reflect it in the y-axis? The x-axis, the x image is the original x times -1. So it's a negative x. So the image of x will be the opposite. What happened to the y value? The image of the y value doesn't change from the original y value. Here, the height was 2, and here the height is 2. The y values did not change. So these two equations, you get that the image is the opposite of x, and the image of y doesn't change. I got that by looking at the specific points. What's the next step? Get x on its own. X is negative x image. Y is simply y image. We can come up to this equation, replace the y with y image, replace the x with negative x, and there's your answer for 1. It is y equal 3x squared minus 5x plus 1. How'd you go? Did you get that in the first one? So a reflection in the y-axis. Let's look at the reflection in the y-axis. What happens to the x value? Brendan? What happens to the x value? Lynn? What happens to the x value? Tan?
It all becomes negative.
Yes, so when you reflect in the y-axis, all the x's flick over to be negative x. What happens to the y value, Tan?
They stay the same.
They stay the same. So really all we had to do for question 1 is change each x value to negative x. So all you had to do is change that to a negative x, change that to a negative x, like here, and then sort it out, simplify it. Okay, so that's a reflection in the y-axis. Just remember, the x becomes a negative x, the y doesn't change. Okay, if you had a reflection in the y-axis, just momentarily, if it reflects on the y-axis, it would go from 2, 3 down here to 2, negative 3. What happened to the x value? A reflection in the x.
It stays the same.
Yeah, it doesn't change. So that means you leave it as 3x squared plus 5x plus 1. But what happened to the y value?
It becomes negative.
Yes, so you would then change the y value into negative y and leave the x's as they are. All right, but we didn't have a reflection in the x-axis. All right, question 2. What do you notice? I'm going to now ask you to do this part down here. All right. Okay, try a second question. Try to work out what happens, what is the image of X and what is the image of Y when you scale factor 3 from the Y-axis. What is the X image value and what is the Y image value? Is that reflecting? Is that sending? I'm trying to push it and it just, yeah, okay, it's pushed. All right. Just for the second question only. What happens? How do you get the X image and how do you get the Y image? For a dilation of scale factor 3 from the Y-axis. The X image, what happened to the X value? And the Y, what happened to the Y value? To get to the image, what do we do to the X and Y point? So the X image equals what? What happens to the, how do you get the X image from the original X value? That was correct, Shin. Shin, you were on track. What happened to the 3, the Y value, when you push it away from the Y-axis? It doesn't change, right? Because it's pushed away from the Y-axis. It's 3 times the distance from the Y-axis. So the original point, it was there. The image point, it's 3 times the distance away. What happened to the X value? Yes, all right, good. Right, that's correct. Okay, you're on track. All right, so let me continue now because you've started correct. Let me continue. I better share my screen so it comes up on the video. Share my screen. It's disappointing when someone misses this lesson because this is an important, very significantly important lesson. And if you miss this lesson, you're going to have to struggle through the recording, which isn't the same as being live in the lesson. All right. When you dilate away 3 from the Y-axis, the X value simply becomes 3 times the original X value. So 2 became 6. And the Y value didn't change. So the image of the Y is the same as the original Y. Okay. Therefore, getting X on its own, X is the image of X divided by 3, and Y doesn't change. So for the equation, you replace the Y with Y, so you don't change the Y value, so it's still Y. So we're just going to put Y equals the Y image, and we change the X into, X over 3 squared plus 5X over 3 plus 1. Okay, and there it is. That can be simplified into Y equals 3, actually 3x squared over 9. 3x squared over 9 would be x squared over 3. Is that correct? Will that be right? X squared over 9 times 3 will be x squared over 3. Yeah? And 5x over 3, that stays as 5x over 3 plus 1. And there is the equation. There's your answer for number 2. What happened? Just look at this equation. For dilation of scale factor 3, what did we change our x into?
X over 3.
X over 3. What if it was a scale factor of by 4?
X over 4.
Yes. What if it was a scale factor of a half? It's only half the distance from the y-axis.
x over 0.5.
Yes, which becomes 2x. See, x divided by a half is the same as 2x. So it's, you put the 2 on top. Like if it's half, you become 2x. If it's a third, it's 3x. If it's a quarter, when you divide by a quarter, that's the same as. To divide by a half is the same as times by 2 over 1. Yes? Okay. Question 3. I don't think we need to talk too much about this because you know that the x is going to come back 2 and the y is going to go up 1. Therefore, the x will be the x image plus 2 and the y will be the y image minus 1. So therefore, I will make that a y minus 1 equals 3x plus 2 squared plus 5x plus 2 plus 1. Okay, you could bring that minus 1 across to be plus 1, and it would simply end up for being plus 2. Okay. Y minus 1. Y minus 1 equals 3. X plus 2 squared plus 5. X plus 2 plus 1. Just watch very carefully. 3. This is not x squared plus 4. If you don't know how to do that, you need to learn that little step that I just did just then. You can't do it, and I notice that some of you cannot do that skill in your homework. 3x squared, 12x, 12, 5x, 10, y equals 3x squared, 17x, plus 12, plus 10, plus 22, plus 1, 23, plus 1. When you bring that across, 24. Okay. Just a bit of algebra. Okay. X image is x plus, what did we do? Negative x. Okay. Y image is y. What does this represent? What type of transformation does this represent? Who can tell me? What is that transformation? What is that transformation? Too slow. Reflection in the y-axis. You can't remember that? We did that 5 minutes ago. Does that look familiar?
Yeah.
Okay, watch what I'm going to do here. Negative x plus 0y equals x image. Oh, I added this plus 0y, wasn't there. There's no x in here, but there is a y. 1y plus 0x equals image y. See what I've done? I just added there's no y component. So this means that there's no y component in this equation, and this means that there's no x component in that equation. Does that make sense? Did I lose you?
Yeah, but
Okay, let me do that one again. Before I do this line, do you understand the line above? Do you understand where I got that from, that line above? You know where I got the line above it? This line here.
Yes.
Okay. All I did was I moved it around to get x on its own. And a reflection in the y-axis says that the x becomes negative and the y doesn't change. And I've just put x on its own here. No, actually, I didn't put x on its own. I didn't. I just moved it around and put this on the right-hand side. That's all I did. All right? Okay. Does that look familiar? 3x plus 2y plus equals 7. What is that? That's a straight line, right? Is that a straight line?
No.
Really? 3x equals 7. X equals 7 over 3. That is the line x equals 7 over 3. It's a vertical line. Yes, it is a line. It's a vertical line. 3x plus 2y equals 7 is when x is 0, y equals 3.5. When y equals 0, x is 7 over 3. And it would be, that's the first equation. And that's the second equation. They're straight lines. If I have a 0y, I've got a vertical line. What would happen if I had 0x plus 2y equals 7? What would that line look like?
A horizontal?
Yes, at 3.5. Yeah? It would be up here. Notice, do I need to say 0x? Can I just say 2y equals 7? What is 0 times x?
0.
0. Do I need to say 0x?
No.
No, not really. But can I have it there?
Yes.
Yes, because 0x simply means nothing. All right. Is there a y component in this equation here? Can you see any y components?
No.
No. So this is negative 1x and no y's. That's all I did.
Oh.
You see that?
Yeah.
Okay. Your turn. What would the next equation be under the y if there's no components for x? Just rewrite that. Put the x first and the y second. What would that look like? Okay, correct. All right, that's correct. Well done. Okay. So there's no x, and there's one y, and that equals. All right. Do you remember yesterday's lesson when I turned this into a matrix? This first equation is negative 1, 0. The second equation was 0, 1. xy equals the image of x and the image of y. Okay, have a look at that very carefully. Where did I get negative 1, 0 from? Where did I get negative 1, 0? Where did that come from? Came from my first equation. Where did I get negative 1, 0 from? You can't see it?
No.
Okay, it comes from here, -1, 0. Now can you see it?
Yeah.
Okay, it's the coefficients of x and y. So my next question is, where did I get 0, 1 from?
From the second equation.
Yes, from the second equation, 0, 1. It's the coefficients of x and y. Yes? And look over here on the right-hand side. Over here, I've got one matrix with the x image, y image. Where did those two come from? See on the right-hand side up here in equation 1, you've just got an x image. All right? And on the right-hand side of equation 2, on the second underneath, you've got a y image. Okay? Do you remember matrix multiplication? Let's multiply. Speak me through. Tell me what to write for the first matrix multiplication. All right, what do I write?
Negative 1 times x.
Yes.
0 times x.
Plus. Plus.
0 times x.
No, it's the second
Plus.
one with the second one. So the first one, -1 times x. So we're going across we go across this way, and we come down this way when we multiply. The first one with the first one, the second one with the second one. So it's -1 times x plus
0 times y.
0 times y equals, we're in the first row, right?
The x image.
Equals x image. Okay, so your turn to do the equation for the second row. Do the equation for the second row. Oh, I missed the image mark up here. No, no, there was no image mark. Sorry. I don't know what I'm thinking. Let me just rub that out. We were correct. It's just -1 times x, 0 times y equals x image. Okay, good. How you going with this multiplication, Shin? Shin, are you there? You finished? No? Okay.
Yeah, but I don't really know.
Okay, let me do it. We're doing the second row now. And to multiply the second row with the first column. So it's the second row, right, with the first column. Okay. So the second row with the first column is the first number with the first item. So we multiply 0 times x plus. Now we do the second element with the second element here. So it's 1 times y. Then we're finished. We go across. Now over here, we've got y dash. Okay, so you have to go across the second row with this column here. All right, so you go across and down. So in the first matrix, it's the first element with the first element, 0 times x. Then you go across to the 1, but you go down to the second element, y. All right? Can you see these equations here are the same as these equations here? Can you see that equation 1 is the same as equation 1? Equation 2 is the same as equation 2. Can you see that?
Yeah.
Okay. Huh. Let's say we had to use the matrix. We have to use the matrix transformation or a reflection in the y-axis to transform the point 2, 3. What's our answer going to be, by the way? What's our answer going to be? What will our point transform to? Where will 2, 3 end up? When you reflect 2, 3 in the y-axis, where will it go?
-2, 3.
Thank you. I don't like waiting too long for answers, but we really only have an hour. That's what our answer is going to be, right? But what does the process look like? Well, what's the matrix for reflection in the y-axis? It is -1, 0, 0, 1. Yes, you have to know that, okay? I don't even think it's going to be on your cheat sheet. You have to make sure it's in your own summary notes. What matrix do we use to reflect it? Now, our x to y point is 2, 3, all right? Okay, show me the multiplication. Oh, let me just do this one for you. Okay, it will be -1 times 2 plus 0 times 3. Okay, that's the first row. Now for the second row. I'm going to go now, the second row will be 0 times first element, 2. Second is 1. We come down under the 2, we get to the 3. Okay, equals. And what's -2 plus 0? -2? What's 0 plus 3? 3. Okay, that's our answer. Okay, therefore, it will move to the point 2, 3. -2, 3 is the answer. Therefore, the answer is. Okay, let me ask you to do part B. Use the matrix to transform the point -7, 5. Okay, same question, but different point, not 2, 3, but 7, 5. Okay, good luck. Oh, I wasn't sharing that screen. Let me just. Okay, so what is the use matrix transformation to reflect in the y-axis to transform the point -7, 5. Yeah, that's correct, Shin. You are using the correct matrix. By the way, the -1 in that x position says that x will become negative. The 1 in the second row means the y won't change. It's just a 1. The x means we're not going to use the zeros means we don't use those other coordinates in the calculation. Brendan, how are you going? Brendan, are you there? Yep, good. You got it. Lynn, are you still with us or not? Doesn't sound like it. Okay, video on. Just cam on for a second, folks. Yeah, I thought that would happen. All right, no cam for Lynn.
Sir, my Wi-Fi was so slow. I can't like catch you at that moment.
All right. I hope you're writing in your book because your pen works on your book, right? Are you writing in your book, Jing Lin?
Yeah.
Okay, good. You can always scan your work in on your book, and that would be, I'll use that to supplement. So if I get nothing on your whiteboard, but I get a scan of your textbook, what you do in class, just scan it to me. I will use that information. Otherwise, if I have 0 on the whiteboard, I'll put 0 for classwork. But if you scan me your work, I will not give you 0 for classwork. But if I don't see the whiteboard, if the whiteboard is empty, I'm naturally going to put 0 because it means some students don't actually participate. Okay, well done. You're correct. What I've seen, you've got -1, 0, 0, 1, and you've got the point -7, 5. That would become -1 times -7 plus 0 times 5. And the second row is 0 times -7 plus 1 times 5. So we've got 7 and we've got 5. Therefore, the answer is 7, 5. Okay, now let's go one level further. One level further. What if, just stop sharing for a minute. What if we get a question which says, let's just, get the right syntax here. Okay. We say a transformation T. A transformation T. Now, when we see a transformation T, it means that T represents a transformation, not a function, right? Such that, all right, such that, just like functions, all right, it's different terminology. The real value, 2, this means two-dimensional. It means we're going to transform a two-dimensional equation. It has an x component and a y component. It's not just the function of x now. It's a two-dimension, means we're dealing with a Cartesian plane, x and y. That's two-dimension. We'll map to somewhere else to another two-dimensional location. And we're going to now put, well, we've got to say what our function for t is. We've got to say what is the transformation that we're dealing with. But we don't have t of x. We're going to have, it looks like this. It doesn't look like t of x. It looks like a matrix. So we have some point. We're going to transform a point, like transform the position 2, 3. This is our original xy point, all right? That's what we're talking about, and it's going to go to some image point, right? So what we're going to see is where will that image point go? And let's say that that image point will go to, let's say that that image point will go to, let's put now the matrix, -1, 0, 0, 1, and we transform our image point, and we transform our image point, x, y, right? And we add like 5 and 2. We add 5 and 2. Okay. Now the question says, maps the graph of a function. We'll just get rid of this because that's not part of the question. That's just what I'm talking about. Maps the graph of a function f to the graph of I don't think we need to put the f of x. We just say f. Function f maps the graph of the function f is it? To the graph of +1, okay? And we just say x is an element of the real numbers. Okay. Does that question look awkward to you? Does that look awkward? Does it look awkward?
Awkward as in like,
It's new, right?
yeah.
Okay. Let's take this part of the graph. Can you translate? Can you see what's happening here? Do you know what it is? If you were to look at that, what is it? What's that matrix represent?
A reflection on the y-axis,
That's
and
first.
then
Yes, that's the first transformation. Transformation 1 happens to be, that is a reflection on the y-axis. Okay, what's the next transformation do?
and then move to the right
Yes,
by 5 units,
that's correct.
and then move up by 2.
That's correct. Now, are you able to do that to this equation here? So it maps No, actually, you can move a function, but the thing is, careful with this question. This says it moves some function to this function. This is the actual answer, right? This is the most difficult part of this question is the answer. You've got the answer. You haven't got the original function. All right? So what we're told is we have to take, we have to work out what is the function f. What is the original function so that it moves to this equation here? All right, we've been doing it the other way. We've started with a function and we've moved it to this function. All right. What would a reflection 1 do? Reflection 1 would change the x's into
negative number.
Yeah. Transformation 2 would then make that negative x and it would -5. And then transformation 3 would just stick a +2 on the end. That's one way to do it. Yeah? Yeah? Okay. I want you to do this. I want you to follow me, okay? Look what I'm going to do. You watch. Because this is an exam style question, all right? Today I'm giving you an exam style question. You need to be able to do this in the exam. So I'm going to take that equation and I'm going to just do what we've just done. Okay, expand this, please. Expand this out. What will this become? First row. Read it to me.
-1 times x plus 0 times x.
-1 times x plus
0 times y.
Yes. Keep going.
Plus 0.
No, stay on the first row. So we've done the multiplication, but there's more on this first row. Stay on the first row. We're here now.
Do we -5
No,
because
no,
we're going back?
we're expanding. All we're doing is expanding. -1 times x plus 0 times y plus
+5.
5 equals image.
Image.
Okay, that's equation 1. Okay, what is equation 2?
Zero times
Zero.
x
0 times x
plus 1 times y
plus 1 times y
plus 2
plus 2
equals y image.
equals y image. Now, this is y image, x image. That's the trick. Because our question gave us where it's going to map to, right? It maps to the graph. This becomes the image. This is the image function. This is x dash y dash. So all you have to do is replace x dash with that and replace y dash with that. You see what I'm saying? What is y dash equal? What is y dash equal? Y dash. What am I going to replace y dash with? What does y dash equal? What does equal y dash? What does y dash equal?
y plus 2.
Correct. Okay, y plus 2. Good. That's what I'm replacing y dash with. All right, what does x dash equal? What's x dash equal?
Negative 5.
Sorry?
Negative x plus 5.
That is correct. All right. Therefore, if I just get y equals 3 negative x plus 5 squared plus 2 minus 1 becomes plus 1 minus 2 becomes our answer. And there is our answer. Okay. Folks, we've done a full hour and I've only been talking about the matrix to do with a reflection in the y-axis. That's the only matrix I've spoken about today. There is also a matrix reflection in the x-axis. There are other matrices. You can read about that in page 136. Cool. And I am going to, and exercise 3I, see what you can get started. Next lesson, let's work through some of those in exercise 3I and see how we go. Try a few. Okay, difficult lesson, difficult concept. That was a past paper question from 2013. All right, that's the style that I need you to be able to do. Have a happy day, folks. Thank you for your patience going full distance today. But I did say it's a very important lesson. If you don't grasp that concept, there will be points you will not get on the test. All right? You will miss those marks. I don't want you to lose those marks. I want you to get those marks. All right? Okay.
Thank you, sir.
All right. Have a happy day.
Thank you, sir.
Good luck.